Hello, welcome to Astronomy Science class. This is the third class for the distance unit of astronomy. In this class, we will learn about Parsec. If you haven't studied the astronomical unit and light year, please watch them too. Night sky, you can observe the pretty stars and you can dream whatever. Let's get back to science. How can you measure the distance of the star from the Earth? Can you measure the distance with a ruler? All of us know it is impossible. We cannot reach the star at all. If we cannot do the direct measurement, we can do it another way. Distance expressions. Before the speed of light was a well-constrained parameter, astronomers developed many methods to measure and express distance that is still used. One important astronomical measurement technique is based on triangulation, trigonometry, to find the distance to a point in two-dimensional space. 3 points are needed using a triangle. This forms the basis of parallax. Here is a river. A girl comes and she wonders the distance to the tree across the river. Can she measure the distance to the tree across the river without swimming over there? Yes. We use triangle, trigonometry. First, she measures the distance between A and B, and she can measure the angle between the tree and the position A at the position of B with a protractor. Then draw a line. And you can draw this triangle on paper and measure it. So if you know the length and angle of one side of a triangle, you can find the length of the other side. Trigonometry. Trigonometry is a basis for measuring parallax. Imagine you can walk from A to B, but you cannot reach the tree C. You can calculate the distance to C by measuring length A and B and angles BAC and ABC using trigonometry. Parallax refers to the apparent greater displacement of moving objects in the foreground relative to the background. The term is derived from the Greek word meaning alteration. Here are the eyes. Two eyes mean two viewpoints, viewpoint A and viewpoint B. In front of you, there is a yellow star close to you, and there is a distant background, blue, white, red background, further location. Let's close your right eye. With your left eye, please look at yellow star. Then your view from the left eye is like this. The yellow star is in front of a blue background. Now you can change your eye. Close your left eye and look at the yellow star again. How do you view the yellow star with a distant background? You look the yellow star in front of a red background. This is parallax. The yellow star does not move at all, but with your eyes changing, the yellow star appears to be moved by your viewpoint changing. Who moved? Your eye moved. Let's do that again. Parallax. Now we have one more star, a pretty shining, glittering green star. But this green star is located a bit farther away from you. Green star is a bit far away. Close your right eye again and find out the position of both yellow star and green star. You will see both yellow star and green star like this in front of blue distant background. Remember their position from your left eye's view. Now change your eye. Close your left eye and look at yellow star and green one again. How do you view the yellow star and green star with the distant background. Now, do you remember how much shift has done for both yellow star and green star with respect to the background due to the change of two alternate points of your observation? Close star, yellow one, moved a lot. Far away star, green one, green star, moved a little. Your two eyes can be explained as Earth rotation around the Sun, 6-month apart location. We observe yellow star and green star from the Earth and the Earth's orbit around the Sun in 1 year. So if viewpoint A in July and then viewpoint B is January, 6 months apart. This is the Earth's location in July. At this position from the Earth, you look at the yellow star and green star. From your viewpoints, yellow star and green star seem to be shifted. Yellow star seems to shift a lot and green star seems to be shifted less, but these two stars have never shifted, has never moved. Who shifted? The Earth, the viewpoint. Due to the rotation of Earth, yellow star moves this much, green star moves that much. Yellow star is close to the Earth, green star is farther than yellow star. Parallax. Parallax refers to the apparent greater displacement of moving objects in the foreground relative to background. Close change in apparent position caused by a change in position of the observer. Closer objects seem to move more. Larger parallax. Parallax triangulation. Measuring parallax, the angle ACB becomes smaller the farther away C is. Close position equals large parallax, far away position equals small parallax. So if you see large parallax, it means the star is close to you. Close to you. If you observe the small parallax, it means the star is far away from your position. As the Earth orbits the Sun, nearby stars change their position slightly against the background, comparing the position 6 months apart yields the distance. Nearby stars appear to change their positions more than distant stars do. Star A, star B. Star B appears to move half as much as star A over the course of the year. The greater parallax, the smaller distance. By definition, a star with a parallax of 1 arcsecond is at a distance of 1 parsec. 1 arcsecond equals 1 degree divided by 3,600. The parallax of a star is 1/2 of the angle through which the star appears to move over the course of the year. A star with a parallax of 1 arcsecond is at a distance of 1 parsec. More distant stars have smaller parallaxes. The parallax is inversely proportional to the distance. The distance to a star in parsec equals 1 divided by the parallax of a star in arcsecond. So 1 parsec is the distance from the sun to the star with a parallax of 1 arcsecond, 30 trillion kilometers. For the tip, let's look at how to measure the angle with the protractor. 115 degree. And you can see how small for 1 degree angle. So 1 arc minute equals 1 degree divided by 60. 1 arc second equals 1 arc minute divided by 60. Therefore, 1 arc second equals 1 degree divided by 3,600. Very, very small angle. So 1 parsec is the distance from the sun to the star with a parallax angle of 1 arcsecond. The parsec is defined as being the distance to a star that has a parallax angle of 1 arcsecond. So we call parallax arcsecond parsec. Parallax arcsecond parsec. The distance to a star 1 parsec away is 200,000 times of the Earth's sun distance. So 200,000 AU. So finally, let's look at Finally, let's look at our 3 distance units. 1 AU, 1 astronomical unit. The distance between the sun and Earth, 150 kilometers. 1 light year. The distance that light travels for 1 Earth year, 10 trillion kilometers. Speed of light is 300,000 kilometers per second. 1 parsec is the distance from the sun to the star with a parallax of 1 arc second. So 1 parsec equals 200,000 AU equals 3.17 light year equals 30 trillion kilometers. Thank you very much.